Alright guys, so here is your homework for the review. We will have our test on Wednesday and Thursday. So go ahead and make this go. So it says a circle has a radius of 4 inches. What happens to the area of the circle if the radius is tripled? Alright, so remember we underline in circles, so we know this question, well, this statement is about a circle. And what about the circle? It has a radius of 4 inches. Here's a star by the question. So I'm going to go draw a circle. I'm going to put my radius at 4. And it says, what would happen to the area of the circle if the radius is tripled? So I'm going to draw another circle, and I'm going to triple the radius, which means to take it and multiply it by 3. So that's 12. And it wants to know what happens to the area. So I'm going to find the area. Area equals pi r squared of a circle. So area equals pi 4 squared for this first circle. And I get area equals 16 pi. Now I'm going to go do the area of the second circle. Area equals pi r squared. So I get area equals pi 12 squared. So area equals 144 pi. Now, it said that it tripled. So I went from a small circle to a big circle if the radius tripled. So that means something happened. So since it got bigger, I'm going to put the big area on top of the small area, and I'm going to compare. So if we compare the big over the small, since we went from a small circle to a big circle, so that means my scale factor here should be greater than 1. That's the same ideal coming from scale factors with dilations and similar figures. So if you don't have your own graphing calculator at home, you can go to Desmos or you can use your mental math here. So you can go to Google and you can type in Desmos scientific calculator, and I've been there several times already. So here we go. And I'm going to push the fraction key, and I'm going to go 144 over 16. And that equals 9. So that means that the area is 9 times greater. The area is 9 times greater. And we're finished. Okay, let's go to the next question. It says find the volume of the given object. Alright, so we have a cone down here at the bottom and a hemisphere at the top. So we're going to use two formulas. And then we're going to add the two together so we can find the total volume. So we can say volume of the cone is 1/3 pi r squared times height. And the volume of the hemisphere is going to be 4/3 pi r cubed. And I'll show you what to do with that at the end. So here, since they gave me the diameter, the radius is 6 and the height is 12. So volume equals 1/3 pi 6 squared times 12. You can use your mental math or you can use the calculator. I'm going to do my mental math. 12 divided into 3 is 4. And then 4 times 36, that is going to be 144. So I get 144 pi. And we double check myself in mental math. 36, 4, that's 120. And then 24, yeah, 144. So we get pi r, and then it's centimeters cubed here. And you can get the approximate answer. I'm going to work with exact answers. And then here we get 4/3 pi 6 cubed. Let's see, that's 36, and then times another 6, that's 180 plus 36, 8, 9, 10, 11. That's gonna be 216, and I'm gonna double check my math on that one. 216, yeah, I'm gonna go use the calculator for that one. So alpha y equals 4 over 3. Anytime you can try to use your mental math, use it and then check yourself. Times 6 raised to the third power, 288. All right, so we get volume equals 288 pi, and it wants to know the volume of the whole thing, but this is a hemisphere, so I need to take this answer and divide it by 2, because it's half of it, so divide this by 2. 288 divided by 2 is 144. Volume equals 144 pi for the hemisphere. So I'm going to take these two and add them together to get the total volume. So 144 pi plus 144 pi. And you can use approximate ounces. I'm just working with exact ounces because they're just easier for me to deal with. So this is 88 pi, and it's going to be centimeters cubed. And we're finished. Okay, let's go to the next one. It says the diameter of a circle is 19 inches, so we're underlining. It says the diameter of a circle and what it's about. This diameter is 19 inches. And then it says in the next one, the diameter is extended. So this is about the diameter. And what about the diameter? It's about the diameter. And what about it is extended 5 inches beyond the circle to make point C. So all of this right here is important. So this is what it's telling me about the diameter being extended. It says how long is the tangent segment from point C to the circle? That's the question part. But I'm going to draw a picture. So I'm going to go ahead and draw a picture here. I have a diameter that is 19 inches. Okay, and then it says it's extended 5 more beyond the circle to point C. So that means I put 5 here. And it says how long is the tangent segment from point C to the circle? So I need to draw a tangent, which means to touch the circle once, and it wants to know this part. Okay, and that's my point of tangency right there. So I'm going to use this formula. So we get x squared equals outside 5, and whole is going to be 19 plus 5, which is what, 24. Yep. And then we get x squared equals 5 times 24. So what is that going to be? 120. And then we're going to take the square root of that. We're going to drop our line on here. The x is on the correct side, so we take the square root of both sides. And we're going to get x equals, and I'm going to go use decimals to help me out with that. Square root of 120 is 10.95. And we got it. And are there any units? Yep. So it's going to be 10.95 inches. Okay, done with that problem. This question here tells me to find the measure of angle F. So that means I'm finding this part right here. So that's my angle. And it's an outside angle, so this is a little arc. And this out here is the big arc. All right, so the formula I need to use is 2 theta equals big arc minus little arc. So 2 times 22x minus 1 equals, the big arc is 215, the little arc is 27x plus 4. And please be careful, make sure you put these in parentheses when you substitute them in. So here I get 44x minus 2 equals 215. This is a negative 1 right here, so distribute negative 27x minus 4. On the right side, I'm going to go ahead and combine like terms. So 211 minus 27x. And now I'm going to go ahead and put my constants on the left side of my line and my variables on the other side. So 44x equals 213 minus 27x. Then I'm going to add the 27x because it goes on the other side. Four, 5, 6, so 71x equals 213, divide into 71, divide into 71, x equals and we get 3. So did we answer the question? It says find the measure of the angle. So no, we didn't answer the question. So now we need to say, since x, the measure of angle F, equals 22, and I need to substitute in x, 3 minus 1. So here the measure of angle F equals, this is going to be 66 minus 1. So the measure of angle F is 65 degrees. And we're finished. All right, let's go to this next one. It says chords AB. So we have some chords, AB and CD. And what about them? They intersect in a circle at point E. So that's what we have going on. And then it tells me some information about it. So all of this is important too. And then it says find EB and ED. Okay, so I need to draw the chord AB. And then I need to draw chord CD. Okay, and they intersect at point E. So that's E right there. And it says A to E is 5, C to E is 10, E to B is X, and E to D is X minus 4. Okay, and it wants me to find this piece and this piece. Well, let me put them in different colors so you don't get confused. And this piece. So in order to find these pieces, we need to find x first. And so since this looks like multiplication, we're going to say 5 times x equals 10 times x minus 4. I'll drop the line down the middle. We get 5x equals 10x minus 40. My x is on the wrong side, so I'm going to minus the 10x. Negative 5x equals negative 40, divided into negative 5. Negative 5, x equals 8. So now that we found x, let's go and find EB. And you need to make sure you answer the question. ED is going to be 8 minus 4, so that one's going to be 4. And ED, and then EB, and make sure you put segment on top of that, and that equals just 8. And you got it. Okay, let's go to the next one. It says find the measure of arc TS. So this is what we're trying to find, and in order to find this, we need to find x. And if you notice here, we have 2 arcs and an angle, and this angle is not a central angle, so therefore I can't say that this is 80. We have to use this rule. 2 times the angle equals the big arc plus the little arc. So we're going to say 2 times 80 equals big arc, and it doesn't matter which one you call what in these problems, because addition is commutative. So here we have an issue. The variables are on the wrong side, so I'm going to go ahead and use the symmetric property of equality to switch the stuff around to make life easier for me. Okay, so here, since this is just a 1, I can take this stuff outside of this parentheses, and since this is a positive 1, I can take this outside of the parentheses, and I can go ahead and do the math here. And then here we get 14x plus, and I'm combining like terms, equals 20 equals 160. So we're going to subtract 20 from both sides. 14x equals 140 divided by 14, divided by 14, x is equal to 10. Now let's make sure we answer the question. Now it said find the measure of TS. So to get TS, then what you need to do is do 8 times 10 plus 15 arc TS, and we get arc TS to be equal to 80 plus 15, which is 95. And we're going to say that is 95 degrees. Alrighty, let's keep going. Okay, so now this tells us to find the length of the arc, the minor arc in the picture. Well, if we look, we have an inscribed angle. Oh no, it said to find the length of the arc. Okay, so that means I need to find how long this piece right here is. And since I'm doing arc length and this is a part of a sector of the circle, there's a few things that we need. So on your formula sheet, you know that arc length of a sector, and I'm going to call it AL, arc length equals pi r squared times theta. No, I'm wrong. It's 2 pi r times theta over 360 because it asked me for arc length. So it said to find the arc length. So here I just need to get the parts. The radius they gave me is 9. Theta I need to figure out, and then I'll be able to find arc length. So theta, I have an inscribed angle here. So if this is an inscribed angle and I want to get the arc, I double it. So this degree of this arc is 120. So that would make the central angle also 120. So we know theta is equal to 120 degrees. Okay, so now I can substitute into my equation 2 pi times 9 times 120 over 360. I'm going to give exact answers. This is in feet. So, and you can do the approximate answers yourself. So I'm going to push my fraction key. I'm going to say 2 parentheses, what we dealing with, 9 and 120, 9, 9, 120, 360 equals 6. So the arc length is equal to 6 pi, and I'm going to put that is in feet. Okay, and you can of course multiply this by 3.14 to get the approximate answer. Okay, so it says Skylar makes lemon pies and pans that are 8 inches in diameter. If she cuts me a 60-degree piece, how many square inches is my pie? So I'm going to draw what they said. So this is about Skylar and these lemon pies. And what about them? They're in a pan that has a diameter of this much. And then there's a question. We'll hold off on the question for now. Let's just draw the picture. So that means the diameter is 8. So each piece of the radius is 4. She's going to cut me a 60-degree piece. So that's my little piece she's giving me. And it's asking me if she cuts me a 60-degree piece, how many square inches is my pie? So that means I need to find the area of this piece of the sector. All right, so the area of the sector is pi r squared times theta over 360. So the r is equal to 4, and my theta is 60, since it's asking about my piece of the pie. So pi 4 squared 60 over 360. So the area of the sector equals 460 and I'm gonna put this in fraction form. Oh boy, I'm gonna put this in fraction form. So I'm gonna say 8 over 3, 8 over 3, or you could do it in decimal, pi, and I'm gonna say, what was the units? It's inches, so I'm gonna say inches squared, because the area is a square unit. Okay, so here's a question now. It says if the arc length is 8 over pi 8 pi over 3, find theta. So here they gave me arc length is 8 over pi. They gave me the radius is 6, and I need to find theta. So the formula I'm going to use is arc length equals 2 pi r theta over 360. So arc length is 8 pi over 3, which equals 2 pi 6, and I'm going to just stick x for theta since that's what I'm looking for, and then 360. So first we got a situation going on, and my situation is my variable is on the wrong side, so I'm going to go ahead and switch the x to the left side by using the symmetric property of equality. And here, we got fractions on both sides. So I'm gonna multiply this side by 360 to get rid of this fraction. And I'm gonna multiply this side by 360. So I get 2 pi times 6x equals, let me go grab the calculator. 360 times 8 is 2,088, and I'm going to go ahead and divide that by 3. So we get 360 times 8. Okay, and then 288, 0. I'm going to divide that by the 3, so we get 960. I'm multiplying these and going ahead and dividing by 3, and since that breaks down perfectly, I get rid of that fraction too. Over here is multiplications, and I only want x, so to undo multiplication, we're just going to divide everything by what we don't want. And so this goes away, and the pi's go away on this side, so we have x equals 960, clear, 960 divided by 6, and that is 160. And what is the units here? It is inches squared. So x equals 160 inches squared. No, I am wrong. That's theta, wrong units. So 160 degrees. Okay, so let's see what's next. Oh, okay. All right, guys. I'll see you on tomorrow. Please practice these. If you can practice these and do them on your own, then you should be fine on the summative. Bye.